So what is the thin filament and thick filament? So look at this image again. So you can see a sarcomere here from one Z line to another Z line. In the middle, this image actually is nicer. You can see it easier. You have the M line that connecting the thick filaments. The thick filaments are connected here. The area that only contains thick filament is called the H band. And then this area from here to here that contains both thick and thin filament, that is called the zone of overlap. And from here to here, then is the A band. Okay, and I band is this area that does not contain any thick filament. So now if you look at it closer, let's go to the thin filament. And the thin filament has 4 different proteins are there. One is the F-actin. So F-actin is a strand, it's a twisted strand that are made of G-acting molecules. So there's a lot of G-acting molecules that are twisted, and that in the middle it is connected by this protein, that is the nebulin, that is connecting the G-acting molecules. The G-acting molecules contains an active site to this yellow area that you see. This is the active site of G-acting molecules, and that is covered by this protein, and that is called tropomyosin. So this one, that is covering the active site of myosin. So normally at rest, the active site of actin, I mean. So normally at rest, when the tropomyosin is covering the active site of actin, then the myosin cannot come and attach to the actin. So that's one of the functions of tropomyosin. And one tropomyosin can cover 7 active site of actin. Then is another protein here that is called troponin. The troponin, one part of it is attached to the G-acting molecule, another part is attached to the tropomyosin, and there is also a free area here that can attach to calcium. So normally when there's no calcium, nothing is happening and the muscle is totally relaxed. You also have something else that's called actinin, and actinin is a protein that is connecting two thin filaments. So one from each sarcomere is connecting the two to each other. And also there is another protein that is called titin. Titin is connecting the thick filament to the Z line. Thick filament to Z line. Okay, so you see the thick filament here, and it's connecting it to the Z line. So the thick filament is made of multiple myosin proteins. So the myosin protein contains a tail. The end of the tail goes to the M line, and then it connects with the tail of the opposite side myosin. It has a hinge, and this area is moving the head, and the head has there's 2 heads here. In a smooth muscle, there's a lot of heads, and the skeletal muscle, there are 2 heads. And these heads are toward the thin filament. There's also the titin that I told you before, and this is one of the very big proteins, one of the longest proteins. It gives elasticity to the myofibril. So it is coming all the way from the M line, goes inside, and then here is twisted, and that goes and connects with the Z line. So in case if the muscle is stretched, then the titin can contract, or if the muscle is contracted too much, then it can spring back. So the main function of titin is to bring back the muscle to the normal length. Sliding filament theory is that I can give you 2 different status, and then it's easier to understand. So normally when the muscle is relaxed, you can see the H band is wide, and also the I band is wide here. There is also zone of overlaps are there, so the thick and thin filament can be close to each other. And when the muscle is contracting, what happens that these heads of the thick filament can attach to the thin filament, and the thin filament moves toward the M line, toward the middle. And in that case, the H band width decrease. Okay. Also, the Z line, the I band decrease here. But the zone of the A band size remains the same, and the zone of overlap size or width increase. Okay, so the I band decrease, the H band decrease, the I band decrease, the zone of overlap increase, but the A band will remain the same. So when the thick filament attaches the thin filament is moving toward the midline. That is the sliding idea. So that's where the muscle contracts, and during relaxation, then it goes back to the length that it was before.